Welcome back. I'm Dr. Angela Siegel, and today we're going to cover solving problems with loops. Like every programming problem, the first step in solving a problem with loops is to understand the problem. So we have to figure out how you would solve the problem yourself. Imagine describing the solution to a friend. What steps would it entail? Next, come up with a few examples and work these out by hand. Finally, ask questions. What are the inputs? What processing needs to be done? What are the outputs? Once you have this better clarified, you're ready to proceed. The next step is to develop an algorithm. So most problems consist of three parts. Input, the step of reading in the input that is necessary, processing, perform a computation or input, and output, print out the results. Developing an algorithm involves problem decomposition. Anytime you're faced with a challenge that's too big, it's because you're taking too big a bite out of the work ahead. Break down the problem into smaller tasks and then solve those smaller components. If it ever feels like too much, break it down a bit further. Combine these small pieces together to build out the complete solution. There are several standard templates that we can use for decomposing our problem, and we're just going to take a look at a few. The first standard template for decomposing a problem is to separate each of the components, input, process, and output. First, you would read in all of the input, which will usually require a loop. You'll store that input in some data structure such as an array. Then, after you've completed that task, you'll process the data. This usually requires one or more loops, and it may require additional arrays or data structures. You may also at this point transform the input into a format that you wish to output later. And finally, you would print out the output. And this may also require a loop, but not always, and it's usually the last thing done. The second template is if you read in the input and process it as it's read. So this will usually require a loop and does not always require the input to be stored. Some processing is done as it is read. Transformation is complete after all of the input is read. Finally, after you've completed the input and processing, you will print out the output. This may require a loop, but it doesn't always, and it's usually the last thing done. A third template is to handle the input all at once and the processing and output together. So for this, you read in all the input, which usually requires a loop, store it in a data structure such as an array, and then you process the data and output the data together all in one loop structure. So this usually requires one or more loops and may require additional arrays or data structures. You transform the input data that you've captured into output, and you print out partial results as you proceed through the loop. Finally, our last template that we'll look at is doing everything all at once. So one main loop, perform all three parts, input, processing, and output all at once. This uses one big loop. The body of the loop comprises of the three parts mentioned. Other data structures, such as arrays, could be used within this, but you read in, input, perform partial processing, and output partial results on each iteration through the loop. I hope that helps. Until next time.
Is that it for loops?
Yes, that's it.
We've wrapped up a lot. I wouldn't even know how to summarize it.
Why don't I try to help?
Yes, please.
In our next video, we'll cover a summary of loops. See you next time.
Thanks for watching.